Hello. Now we're going to look at the concept of variables, things that can change when we are talking about our project for our CBA1 in maths. So we're going to look at two examples now. One, a situation where we might get yet to meet expectations for this part of the project, and another where we would be in line with expectations for this part of the project. So it's important to note each section of our project is judged independently, and we look at the average or what is most appropriate for the overall project. So we're going to look at these sections as in line or to meet expectations, yet to meet expectations. So let's start with yet to meet expectations. The story we've got here is that we want to build a shed. And in this yet to meet expectations example, I'm looking at the cost involved in making the shed. And I've broken up my cost into several different pieces. I've said the total costs are going to be the base of the shed and the walls and the roof. And I've given my example here. I've drawn in my shed. I'm going to have a square shed, and I'm going to have it with walls that are 10 meters long and 10 meters wide. So the area of my shed, the area of the base of my shed is going to be 10 by 10 is 100 meters squared. And the perimeter is going to be 10 plus 10 plus 10 plus 10. So I end up with 40 meters for my perimeter. So I've done some maths here. And I then work out what the base is. So the base is going to be, the cost of the base is going to be the cost per meter squared of the base times the area of my shed, which is 100. And I work out in a separate part of my project, or I find on the internet that my cost per meter or squared is going to be 40 euro. So when I multiply that up, I'm going to get 4,000 euro for the cost of the base of my shed, also called the foundation of a shed. The walls are going to be, they're 10 euro a meter, and I know I have 40 meters for my perimeter. So I am going to end up with 400 euro for my walls. And then for my roof, I am going to have, I am going to have 30 euro per square meter for my roof. Compared to the base of the shed, I'm going to have 30 euro per square meter, and I have the area of the base is 100 euro. So I end up with 3,000 euro. So my cost is 4,000 plus 400 plus 3,000 ends up being 7,400 euro. Why is this yet to meet expectations? So there's some good structure here. I haven't just written down nonsense. So why is it yet to meet expectations? One of the key pieces in our CBA is that we must use algebra. We must use arguments based in maths. So my argument here, my story in this part is written in English. It's not written in an equation. All of the bits of it, I haven't shown here anyway any indication of where this number is coming from. I'd have to give a clear reason for why this cost would be what it is. The same for the walls, the same for the roof. And as I say, I've written out my argument in English instead of in mathematics. I didn't write it as an equation. But absolutely critically, in terms of getting up in the marks, I've given a specific example. I haven't described anything in terms of algebra. This is all constants. This is an example of a situation, not a description of a relationship between things. How does the cost change if the lengths of the walls change? Or put another way, if the area changed? If I made my shed a bit bigger or a bit smaller, what effect does that have on the cost? This is what we need in order to get a high grade in our CBA1 in maths. Can I show that if I make a change to something, what effect will that have on something else? In this case, if I change the area, what effect does that have on the cost of the shed? If I make something that was only 50 square meters, so half the length of my walls, what effect is that going to have on my cost? So that is the yet to meet expectations type of situation. The work is clear. I've given a diagram. I've written out exactly what I'm doing, but I've given my argument in English and I've given a specific example instead of showing the relationships between things using algebra. So let's look at an in line with expectations type example, and I've deliberately gone with exactly the same situation. It's important to note this is not actually the best way to do this problem. I am deliberately only giving a very basic notion. I'm showing you the approach to take, not necessarily the best way of approaching this question. Because if I showed you the best way to approach this question, then you would, for watching this video, you would lose marks for having done something similar. So I am consciously not doing the most mathematically appropriate way of solving this. I am, however, using a very appropriate method for solving this. So you will be able to see clearly the steps that you should take to get a high grade. This is not a method. This is not exactly the approach that you would want to take to do well, but it is exactly the method that we should write for getting a high grade. So let's start off with this table that I've got. What is going on with this table? Well, it's describing all of the terms that I'm going to use, all of the algebra I'm going to use. Every single one of my letters is defined all together in one place, and the units for all of them are given clearly. So that if I run into a letter that I'm not sure of when I'm reading this report, I can go back to this point and say, that's what that letter means. If I see capital B anywhere in this project, I'm going to know that that refers to the cost of the base of the shed. And I know that that's going to be measured in euro. So this is critical to our structure. Are we clearly showing the structure of how we're solving the problem? Am I being very neat and tidy in the way that I'm thinking and describing the problem I'm trying to solve? So everything gets defined very clearly up front. And this would, for our main project, actually be on a separate page or something. It's here just to give you an example of a snippet of the type of method that we need to use to get a higher grade. So the diagram is basically identical to what we had before, but now instead of giving a specific example, I'm describing things in terms of algebra. I'm saying I have a square shed, so its length and width are the same, so I can just call it length and length. Well, what's the area of a square? It's going to be length by length is length squared. And for a little bit that I'm going to do later on, it's useful to think of taking the square root of both sides, and the length would be equal to the square root of the area. This is a little bit more advanced, but is still kind of in line with expectations. Doing a reversal like this would move us closer to above expectations, but it would need to be used in some creative way or used to solve the problem in some interesting way. So this is a little bit more advanced mathematically, but would still be in line with expectations as I have used it here. Now the perimeter we know would be just walking around our shape. So that's length plus length plus length plus length would be 4 lengths. So instead of writing out a specific example, I have written things out in terms of letters that I can then vary. I can vary the length of my shed walls and thus change the size of my shed, and in doing so I'll be able to vary the cost of my shed, and that relationship is what gets us marks. Now here I have the cost total, so the total cost is equal to the cost of the base plus the cost of the walls plus the cost of the roof. All of this is defined here. Now, the cost of the base is going to be, CB is going to be the cost per meter squared for the base. And now I have this 1 in square brackets. And this is a way of making a reference or a citation in a project. If I'm giving you a number, but right here I'm not showing you where that number is coming from, I can put a little square bracket and a 1 and close square bracket, and this is going to be my first citation. So citation 1, and then at the bottom of my project or at another part of my project, I'm going to have all of these citations list it out and show where it comes from. So if I got this number from a website, I'm going to put down the link to that website. If I worked it out somehow, there was steps to how I worked out this 40 euro per square meter, then I'm going to show those steps either here or where the citation is. It's important that we never just put down a number without justification. If I'm saying that something costs 40 euro per square meter, I have to tell you at some point why that would be true. And again, if we don't do that, that knocks us down in marks quite a bit. We need to justify and make sure that our thinking is clear. And so I've just written down what a citation is. State where the number came from at the end of the report. So we'd put down at the end of our report, we'd have a separate page for citations, and we put down 1 in brackets, and next to it, whatever the justification is for getting this 40 euro per meter squared. So our cost of our base is going to be 40 times the area. That's what I've written here. So B is equal to 40 times the area. And you can see as I'm going through here, my costs, my 3 costs that I'm calculating are all written in terms of the same variable. They're all written in terms of area. And this is not actually the best way to do this, as I said, but the key point is I've written everything in terms of a single variable. That allows me to change that variable, one variable, and show how that affects the overall cost. And this is key. So my walls, I should say, are a little bit different because the walls don't relate directly to the area. They actually relate directly to the side length. So I know that the area of my square is going to be the length of the side wall squared. So the inverse of that would be the length of each side wall is the square root of the area. Now that's only true for a square. It is not true for rectangles. So we need to be careful if we were trying to generalize what you're seeing here. That relationship is not true for rectangles in general. So in this case, because I've got a square, I'm able to say that my cost of my walls is going to be the cost per meter squared, or cost per meter, I should say, of my walls. And then that's going to be 4 times the length of each side wall, which is 4 times the square root of A. Again, I have my citation 2, so I need to justify where this number was coming from. And I have 10 by 4 is 40 times square root of A is the cost of the walls. I do something similar for my cost of my roof, very similar to what I did for B. Then I write down my total cost is this stuff added together. I have some like terms here. I have stuff just involving A. So I add them together, and this becomes my equation for describing the total cost. I now have a relationship between the size, the area of my shed, and the total cost of my shed. That allows me to draw a graph. So I can go to a graphing simulator, or I can draw out a graph by hand. And that allows me to say the cost. So I have my cost labeled on the y-axis. So the cost goes up and the area goes up. And this green line that we have here is the relationship between the two. So if I had a 10 meter square shed, it would cost me around €1,000, a little bit under actually, about €800. And to compare to my original situation, I go to 100 on my area axis and go up to my green line and across, and I get 7,000. I get about 7,400 for the cost of my shed that would be 100 meters square. So I get basically the same answer, but I have shown it algebraically. To get into an above expectations type situation, we would now want to compare these things. So I said the cost of my walls was €10 per meter. If I increased the cost, if I got nicer walls, what effect would that have on the overall cost? Could I draw another graph that had higher expenses and compare those things? And that's what we need to do for our variables.